Hello everyone, in our previous video we showed how to analyze lifting using space gas. In this video we are addressing diagonaling effect and how to model diagonaling in space gas. Diagonaling is referred to the situation that may happen when one diagonal or sling diagonal like this takes more load than the other, and it may have some significant effects on the design. But first we will do the analysis of this model, which has been prepared before to ensure that it's been created properly. You'll see at this point, which is a fixed point, it's considered as a hook point. We only have a vertical reaction as it should be, and there are no horizontal reactions, neither on the hook point nor on the soft springs that we put here for stability. So the model is set up properly, and we check the sling loads, and you'll see that the sling loads almost uniformly distributed between the four slings. If I do a design check based on AS4100, you'll see that all the members pass. So it seems to be all good. However, some of the codes require us to include or investigate the effect of diagonaling, meaning that because of the slight changes or slight differences on the sling length or stiffness or size, one diagonal may take more load than the other diagonal. Let's see how we can address this and what is the effect. So in this case I pick this diagonal and I change the modulus of elasticity to much smaller value, which is 9000 MPa. It previously used to be 125,000, all of the slings, but now this diagonal has got 9000 MPa. And after the analysis, we will investigate the sling loads, 40 kilonewtons and 17 kilonewtons. So you see this diagonal has got 40 kilonewtons, almost 41 kilonewtons. This diagonal has got 17.5 kilonewton each. So it's basically a 70-30 distribution between the diagonals. And the effect on the design, on this particular design actually, is quite significant. We can see some of the members are slightly failing, so these members that used to pass now about 3% overstressed, which is not good, but still may be accepted. Some other codes actually require doing the full diagonaling effect, meaning that one diagonal, in this case this diagonal, takes all of their load and the other diagonal takes no load. How are we going to model this in space gas? So if I disable or remove these two slings, I won't be able to analyze this model because it becomes geometrically unstable. Rather than that, what I will do is that I'll release the axial deflection of one of them. So you see what I've done, this is for the X deflection or X stiffness of the member. So I release that one of them only, and we'll analyze to see what happens. The first effect is that it's ill-conditioned. We cannot escape that, but we have to interrogate the model to see how bad it is. You see, Now these horizontal reactions appear, which didn't used to be there, and that's because of the ill conditioning caused by removing one of the slings, but it's still analyzed and the reactions are quite small, so we kind of accept it. In terms of the sling forces, you'll see that this diagonal doesn't have any load in it, although I've only disabled this one, so this one is still there but it's not taking any load, and the other diagonal takes all the load. To investigate the effect on the design, I'll design it again to AS4100. So previously we used to have only 3% overstress, now we've got very bad position here, so 62, almost 40% overstress here, and that's the effect of diagonaling. Thank you for your attention.